Good evening. Is my mic on? Yes. You can hear me? Oh, good. Well, welcome to our town. And this program's been on for about a year and a half now. And one of the features of the program is that it's been free. But I'm going to tell you that that's going to change. So in September, people who are members will be able to come for free, and those people who aren't members are going to have to pay $5. I know. So here's the incentive, though. If you become a member of the Dali, if you become just an individual member at the lowest level, it's $60. So there's 11 our towns throughout the year because we don't do it in December because of the holidays. So if you paid and were non-member, that would be $55. So for a mere $5 more, I should say it should be $60.99, right? I mean, you get the whole museum. You can go up to the collection anytime you want. You get to invited to all other events that they have that will be free for you, and you become part of the community. And becoming part of a community in any museum is a real benefit not only to the greater St. Pete, namely our town, but to every other arts organization and every other person. So we are going to pass out membership forms. So anybody who's interested, Molly and I think Chelsea are going to pass them out. And so if anyone who's not a member could raise their hand, you can get a membership form. Also, in addition to just becoming a regular member, you could also become a sponsor of our town, which would be an extra special thing to do. So we're happy you're here, and we're happy that you would consider being a member, and we hope you come back all the time. I particularly would like you to come back all the time. Tonight we have a guest, Dr. Jyotika Virmani, who really isn't from our town, but now is from our town. And we've been forming this program about things that have helped to shape the identity of St. Pete. Well, one thing that has clearly helped to shape the identity of St. Pete is tropical storms. And Jyotika is an expert on tropical storms. And the way I found out about her was at a party for a friend of mine called Nancy Ellis, her birthday party. And Peter Betzer and Susan mentioned Jyotika as somebody we were talking about storms. Oh, you must read Jyotika's blog. And so...
always Peter's fault.
And Peter Betzer, who's sitting in the front row, is going to be November's Our Town guest. So there's a lot of things to be grateful to him for. And then Frank Biafora, who's the Dean of the Arts and Sciences at USF, also mentioned Jyotika, so I figured this is the person to get. And I've been delighted to get to know her, and this tells you everything about her. Let's see. She is indeed the storm.
Happy now?
Yeah. So, in addition to the storm, Dr. Virmani is the Associate Director of the Florida Institute of Oceanography. And her boss is in the audience. He's sitting in the back. Do you want to introduce him?
Yeah, Bill Hogarth, my director of FIO, in the back there.
And as many of you may know, he is now the interim leader of USF-SP. I think maybe not right now, maybe in 3 days or something.
August 6th.
August 6th. So he will be the interim director because Margaret Sullivan, as you know, left. She was our guest last month, actually. And that's an important job and important to our community. So we look to you for guidance in all of this. And we're glad you're here.
And it's Bill's fault that I'm back here, actually. He has a really delightful story he's told everybody in Florida, I think, about how, when I left, he asked, you know, what it would take to keep me here. Mm-hmm. And I said, I can't find a chap.
Oh.
So, so then he tried, you know, to find a chap, and no luck, so I left. And then I came back, and I found my chap. And I told him I brought my own chap with me.
So, as always, the first question of our town, which she's already started to talk about, is how did you come to St. Pete? And you've come to St. Pete twice. Mm-hmm. So let's start with the first time you came to St. Pete.
So the first time I came was to do my PhD at the College of Marine Science, and my former advisor, Professor Robert Weisberg, is right here as well.
Yes. Do you want to stand up so we can all recognize you?
And so that's why I came. I did a PhD in ocean-atmosphere interactions, initially looking at the equatorial Pacific, and then shifting my focus to the West Florida shelf off our coast here.
And then you left.
And then actually I did stay for a little longer. I did a postdoc in hurricanes with Bob. And then I became the executive director for Florida's Coastal Ocean Observing System Consortium, which is a Florida-wide consortium. And we'll talk about that later, I think. Mm-hmm. And then I left.
And where did you go?
I went to Devon in the UK, to Exeter, to work as a senior scientist at the UK Met Office, which is the equivalent of the National Weather Service.
And what did you do there?
Things. So no, I did research, atmospheric research, and it was more applications on communications and stuff through the atmosphere.
And England's your home, yeah. Where you grew up.
Yes, yes. Mm-hmm. I was born in Manchester. I love Devon. I love the southwest. For anyone who's been to England, get out of London if you get a chance and look at the countryside, because it's fantastic.
And your parents, how did they get to England?
So they're from India. Mm-hmm. And my dad got to England via Holland on a scholarship. And he was a lecturer in economics in Manchester. And he went back and met my mum and got married and brought her over to England.
And what did your mom do?
She did a PhD in chemistry and a master's in computer science. And this is, you know, way back when computers were probably as big as this screen, mm-hmm. With the punch cards and things. And then she's done a variety of things. She, mm-hmm. you know, looked after us. She did her best.
So your dad's an economist, your mom's a chemist, you're a marine scientist, and you have a younger brother.
Yeah.
And yeah. What does he do?
He is a lecturer in Strathclyde University in Glasgow, and he's a quantum physicist. So, yeah. And I did physical oceanography, so I take credit for him.
Well, but you, as the equivalent of an undergrad in England, you did physics.
Yes. Yeah.
Mm-hmm.
Yeah.
So, I wanted to bring that out because, you know, last time Margaret Sullivan was our guest, who was is still the Chancellor of USFP, and we've talked about this throughout this series, the importance of education and what that does. And it's a big topic in St. Petersburg, public school education, charter school education, and the presence of all the universities in Pinellas and St. Pete and Tampa. And Jyotika is such a great example of the importance of education and how one can flourish and a family can flourish with education. And of course, you know, after you listen to her, you'll see she's quite brilliant. There's probably some natural brilliancy here. But without the education, there'd probably be not much. So, oops. Except maybe a storm. But yeah, you get my point. So moving right along. So okay, you go back and you're in the Met office in Britain, and oh, what happens then?
Two things happened.
Two big things happened.
In the same week.
Yes.
There was a volcanic eruption in Iceland that shut down Europe, and the global forecasts for that came out of the Met office. Mm-hmm. So I was drafted. So you envision an environment where scientists are working from 8:39 to 5, and it's the same small team of scientists, and they go to working 24 hours a day. And everybody wants to talk to them, the Prime Minister, the Cabinet, COBRA, the Aviation Authority, journalists. Everybody wants a piece of these handful of scientists. So those of us who were not in that team were recruited to help work with them. So I was helped to manage that team. Simultaneously, more or less, there was a little oil spill in the Gulf of Mexico.
It's amazing. It was exactly the same week.
Yeah, I think the 17th and the 20th or the 22nd.
22nd, I think.
22nd was the oil spill. Yeah, so really, it was amazing. So over there, we were dealing with this massive event, and then I'd turn on the BBC, and there's Bob saying something, or Bill, or, you know, people I knew around Florida. And it was a very surreal couple of weeks, 3 weeks there, I think. So, so that's what happened when I was over there.
And so why didn't you stay there?
Because simultaneously, FIO's former director was...
FIO stands for?
Florida Institute of Oceanography's former director was retiring, and they had a director's search on. And I was in England, and I think I got 7 or 8 emails and phone calls saying, why haven't you applied? Where's your application? From various people around Florida. So I applied for that. But when I applied, it was a very different Florida Institute of Oceanography. This was pre-oil spill, was when the application was due, essentially. And so FIO was evolving during that search, during the search for the director. So to the point where, even though I think it was only 2 months later by the time the interview stage was, the Florida Institute of Oceanography had undergone such a transition. Bill was interim at that point, and they'd got, they were about on the verge of getting an award from BP, part of the initial research that BP had pledged to do in the Gulf of Mexico. So it was a different thing. So in a period of such transition, it was felt better to leave the leadership as it was, because you don't want to destabilize things any further.
Rock the boat, so to speak.
Well, yeah, Florida Institute of Oceanography, you don't want to rock the boat.
There it is.
And so Bill stayed on, and the associate director was retiring at the end of that year, and so as the lead candidate, I was asked to step into those shoes instead.
So will you explain what the Florida Institute of Oceanography is and what it does?
Sure. It's set up by the Florida Board of Governors, and it's one of 3 academic infrastructure support organizations in the state of Florida. And the idea is to support the universities, the state university system. There's 3 things that are too expensive for any single university to handle. There's the university press, the university library system, and Florida Institute of Oceanography with the vessels. And we're a consortium of now 27 members, all the state universities. Oh, there's a picture here. Yeah. It's not me. including the state universities, private universities, non-profit, and we also have a for-profit member now. And we operate 2 research vessels. This is the Bellows. This is our smaller one. This is 71 feet in length, and this is the larger one, the Weatherbird.
And this is the new one.
Yes, yeah. And this is 115 feet in length. And they both go out. We do research cruises, and we do educational cruises, taking undergraduates and graduates out.
But these are the vessels that went to the oil spill.
Yes, I think pretty much any vessel in the Gulf area was called into, from the photos I've seen. Yes, yeah, they did go out. They were very busy that summer.
And USF SP, well, I guess it's USF Tampa is the Marine School.
Yes, the College of Marine Sciences with USF Tampa, and then the rest of the campus is University of South Florida, St. Petersburg.
Right, and the Florida Institute in Oceanography had a great deal to do with the oil spill.
Yes, we were considered the entity in Florida to go to for that. So the 10 million that Florida got came to FIO for distribution and grants. So there were 27 research projects that were done with that.
And what is this?
This is the Keys Marine Lab. This is in Layton on Long Key, and this is something that we also manage, Florida Institute of Oceanography.
And what happens here?
This is actually owned by the state FWC. FWRI owns this.
What's that mean?
Fish and Wildlife Research Institute. That's right here.
Yes.
And we manage it. And people come here to conduct research in the Keys, or they bring classes of students for a week or a few days. So it's kind of a field course type place. And there's dorm facilities. People can stay there. There's lab. There's boats to go out and do research.
So why is something like the Florida Institute of Oceanography, why is that important for our state? Is it special?
Well, Florida is an ocean state. So oceanography it's important for everybody in Florida. I mean, you could live in the middle of Florida and you still would be impacted by the coast and weather systems that come off the coast, for example, on either side. So to have a strong oceanographic education and research in Florida is really important, and we work with all of them around the entire state.
And do you work in relationships to other states as well?
Yes, yes, we do. And we work all the way from North Carolina to Texas. So with the oil spill, for example, the other Gulf states saw how well Florida responded by virtue of having FIO. And so they established similar entities within their states, and now all 5 have got together and they form a unified voice. And in fact, Andy, who's standing there, is the executive director for that entity.
And what is his name?
Andy Shepherd, Dr. Andrew Shepherd.
Well, good.
He's housed here with us. He sits across the hall from me.
So what you're saying is Florida was a real model for the other states.
Yeah, that's what I've, and I hear that from the other states too.
So one of the things that's happened recently is there's been an announcement about funding that you may receive. Could you tell us about that?
The Restore Act. So BP, when the oil spill happened, they immediately pledged funding for research, $500 million, over the next 10 years. And then there were other pots of funding money that they had to pay. There's penalties and fines and this, that, and the other. One is there's a damage assessment, economic and environmental. So they're going to have to pay for the damage that was caused. Another one that you hear of is the lawsuits, the small businesses and people who were independently harmed. And then the other one is a penalty that's, it's a fine from the Department of Justice, so it's the federal government that will be fining BP for damages. And that they're still working out the details of that one. Could run anywhere from $5 to $25 billion.
Billion?
Yes. And it depends on the number of barrels of oil that were spilled. And so that's the
And who
that's
will
the
get
uncertainty.
that money?
So normally that would go to the federal government to do what they need. But the 5 Gulf states legislators in DC got together and have just had a bill signed about two weeks ago, was it? Yeah.
And Senator Nelson was
Senator
here.
Nelson was one of the authors of this. And it essentially says that 80% will come to the 5 Gulf states for the damages that were caused in the Gulf of Mexico to mitigate some of those. And then within that, it's divided, so a certain amount will go to the states themselves, a certain amount will go to other entities, and then 2.5% of that will go to establishing centers of excellence, one in each of the states. So 0.5% will, I know, but I mean, you're talking about 5 to 25 billion, so
right.
0.5% I will take, that's fine. Will go to each state to establish a center, and within that,
So that's about what, 40 million, 50
it
million?
could be anywhere from there to about 100, 120 million. You know, I'll take that. I can live on that. No, so that will come to a research consortium, a consortium of research institutions that include DP and FWC. And that's
What's DP and FW?
Oh, sorry, Florida Department of Environmental Protection. So the two state agencies, and that's who we are. That's the consortium that FIO is. So
So you'll administer all that?
yeah, that's
That's great.
pretty much
Right here in St.
right, Bill.
So
So that's we don't know when. We don't know how much. We actually don't know much more than that, to be honest.
so that's your official administrative hat.
Oh, okay.
And then you have this other aspect,
yes.
and is that you're a tropical storm expert. And this is your blog. It's called Jyotika's Tropical Storm Blog. And you can find it at jotikastorms.blogspot.com. And as I understand it, people from all over the world read your blog.
It's a pretty broad readership, yes. Yeah, see, if I knew if it was going to be that popular, I wouldn't have stuck my name on it. I mean, that's not very incognito at all. Yeah, no. I mean, how can I complain?
Right.
Everyone knows who's complaining. Yeah, so this started...
Oh, that's true, isn't it? So you can't say, well, so-and-so doesn't know what they're thinking about, because they'll know.
Officially I can't, but I don't think it really stops me.
So do you want to talk briefly about your blog before we move on?
Sure. So this started in, I was here for the 2004 and 5 seasons. I don't know who else was in Florida for those. Yeah, a few, yeah. And so I was a student then, and I was doing, with Bob, I was studying ocean atmosphere.
You were a graduate student.
A graduate student, yeah. And I graduated in 2005, so with a PhD. So I was close to finishing. And I just had an interest in following these. So in 2004, I'd have my screen with them, and everybody would come into my office and say, what's the latest, what's going on? And then my neighbors back at home were also very obviously interested in what was going on. And there was a day when I drove home, and Candy and one of my other neighbors, Elise, I don't know if she's here. Oh, there she is. They were standing in the driveway. I'll never forget this. They were chatting, and they were actually waiting for me to turn up so they could ask what was going on. So I found that by the end of 04, beginning of 05, I'd wasted so much time telling everybody the same thing that I set up an email. And it had 10 people on the email. It was easy, no problem. Then someone said, oh, could you add so-and-so? Or could you add so-and-so? So by the end of 2005, I had 50 people. So the college set up a list for me to make it easier instead of me writing everybody's email address. And then in 2006, a friend of mine said, well, you're calling it a blog, so you should have it as a blog on a website. So he set up the website, and it's just grown and grown. Word of mouth, it's just grown. It's got, I don't know how many thousands. I mean, the website's it's close to 30,000 hits on the website alone. But yeah, so that's it. And it's just whatever comes into my head. As you may have found out if you read it. Sometimes it's science.
It's what comes into a senior scientist's head who knows a lot about storms.
Yeah, sometimes it's science, sometimes it's not. Sometimes there's a science fiction reference.
Yeah, right. Which is a big interest of yours.
Yes. Hence that first picture.
Okay, so let's talk about tropical storms. So this is a map of the world.
Yes.
And do you want to explain what this is?
Sure. So this is a map of all the tropical storms. I think this is until 2006, but I mean, you don't really need to know more than this. So here's the North Atlantic. There's Florida. That's where we are. Gulf of Mexico. This is the Pacific, and this is the Indian Ocean, South Pacific and South Indian Ocean. And so what you see here is along the bottom, you've got this color-coded from tropical depression, which is in blue, to a Category 5 storm, which is in red. You see there's an awful lot of Category 5 storms that occur on the Western Pacific.
And those are all called typhoons.
That's right. So each basin has essentially a different name for the same system. So for the Atlantic and the Eastern Pacific, they're hurricanes. In the Western Pacific, they're typhoons. And then in the Indian Ocean, they're cyclones. And also in the Southern Pacific and Indian Ocean.
And do you know why they have different names?
Yes, because it's based on their origin. So hurricanes, for example, are from the Mayan god Huracan, who was the creation god. So that's where hurricanes come from, because not only did he create, he also destroyed. That's what you do. Cyclones, I think actually cyclones might be a Greek word, if I remember correctly. And typhoons, I think, has its origin in Chinese. So it's how the local people describe them.
And what's interesting about this map is that there's two horizontal lines. You know, it goes this way and then this way. And, you know, I would always think of hurricanes as, you know, they just happen in certain wherever. But this map really shows you that there's a real pattern of where they occur. And do you want to explain a little bit about that? Do you want the high-low map, or do you want to explain it a little?
Let me explain. I mean, this is essentially, there we go. This is the equatorial region, essentially. And that's where you don't have hurricanes. And the reason is, I'm going to go into science here, Coriolis, because hurricanes need something called the Coriolis force. And that is dependent on how far north you are. Its strength changes as you go north or south in latitude.
From the equator.
From the equator. So there's no Coriolis force, or very weak, around the equator. And the Coriolis force is, it's an apparent force. It's not force like gravity. And it's because we live on a rotating planet. So if you imagine yourself on a roundabout, you and me.
A roundabout.
Like a kid's, what do you call it in this country?
A merry-go-round.
Merry-go-round, whatever.
Carousel.
Yes, carousel, okay. So and I threw
am I on a horse that goes up and down?
You can, but it's not moving yet.
Oh, okay.
So before it starts, I throw a tennis ball at you,
okay.
and you just catch it, no problem.
Yes.
Now, if it's moving, right,
Right.
and I throw a tennis ball in that direction and you've moved over here,
Yes.
then that ball, if you were looking at it, would have deflected,
Yes.
right?
Mm-hmm.
Just from your vantage point. It's coming at you, and then, whoa, it's not coming at you anymore. That's what the Coriolis force is. And in the northern hemisphere, if you are moving... Oh,
Let me go back. Sorry.
there we go. So if you're moving from...
Here to here?
Yep. If you're moving from east to west,
Yeah.
it deflects to the north.
Ah.
Okay? So that's the Coriolis force.
Can we observe one more thing about this before we go on?
Sure.
It's very interesting that South America just gets this
Very
little
few.
thing, right? Can
Yeah.
you?
Yes. My understanding is that the reason for this is because there is a lot of wind shear across the South Atlantic.
And that's one thing that
And
disturbs
wind shear
hurricanes
is not conducive
to the development
to
of a
development. Yes. The
hurricane or
other
a
reason
tropical
is,
storm.
I think, because to get this development going, you need to have a specific gradient, a temperature gradient off the land. And so you hear of African easterly waves.
Right. They come
off
across
here
up
and they
top,
become
yeah.
destabilized. And so, but I think really the reason is there's a lot of wind shear down here.
Okay, so now another thing, this is another, okay, there we, whoops. Oh, another map of the world, and this shows patterns of low and high pressure, which is also relevant.
Right, so these are yes, these are also relevant for that, semi-permanent high and low pressures. So we have one here. This is, I'm going to just focus on the Atlantic because it's much easier. This is called the Bermuda Azores High, and it sits in the Atlantic all year long, and it shifts. Sometimes it'll be over here, sometimes it'll be elongated and not round, sometimes it will be here. And wind or currents or anything move clockwise around a high pressure system. And so when you looked at that map of the hurricanes, they were all going clockwise.
Right.
They're going clockwise around around this high pressure system, the Bermuda Azores High. So if you want to, do you have that?
Yes, I do. And just to, you know, again, we have horizontal lines, different from that other, but it's very interesting how this sets up.
Yeah, so these are highs. You see there's a certain symmetry, and then there's a low, and then actually what you don't see is another high north of that. These are set up by movements of air, but in a north-south direction, because the equator warms up more than anywhere else.
Yes.
Warm air rises, and so it has to go somewhere. And so it goes north and south. And where it comes down is where these high pressures are. So there's, if you can imagine it, it comes out and then round and down here. And so there's a loop that's set up. And then another one here, so it's all about air movement, but in a north-south direction.
Okay, so.
Oh, there's the Bermuda Azores High.
Yeah.
Right. I think we've already covered this one.
Yeah, but it's a great picture.
Yeah. Yeah. So yeah, basically that's it. A hurricane will follow. That's essentially the track.
And the high won't allow the hurricane to go. It makes a barrier.
It has to go around this.
Yes.
It does. Yeah. Yeah. A hurricane is a low pressure system. So as things go clockwise around a high, they'll go anti-clockwise around a low. So when you look at a hurricane, the winds will go anti-clockwise. So this is okay. This is from January, February, March, April, May, June, July, August, September, October, November, December. This shows the Bermuda Azores High through the year, and this is a climatology. So it's taken over a number of years. I think it's like 52 years or so. And it just gives you an idea of how it changes through the year. So our hurricane season, June, July, August, September, October, it's quite curved and over towards the US coast. And then in the winter months, it becomes a bit more, it actually shifts a bit more to the east and is a bit more The high pressure is a bit more elongated.
And so when it comes in the summer months, closer to us, and that would then direct the hurricanes and tropical storms towards land, towards the U.S.
Yeah, that's it. Okay, so this is another plot I made when I was a grad student. And this shows all the storms from, I think it was from 1851 to 2005, if I recall correctly. And so on the top it's January, February, March, April, May, June, July, August, September, October, November, December. And there's a couple of interesting things about this. One is you can see that there's a storm in every month, but it really picks up during the hurricane season. And about 97% of the storms occur from June to November, and that's why we have a hurricane season. But you can get storms in other months, as we saw in 2005, in fact.
Right.
And the other interesting thing is that early in the season, they form closer to the US coast, to the Western Atlantic. And then as you get further into the season, they form off the Eastern Atlantic and come all the way across. And then again, as you get towards the end of the season, they come back and they start to develop Gulf of Mexico, Caribbean, this side of the Atlantic.
And when we go through this, let's talk about why, you know, the Indians who lived here thought that this was a safe place for storms. But let's go through this first, and then we'll talk about that.
Oh, okay. So here I was saying, you know, if you imagine it goes clockwise. Here's a clock face. So so that's how the storms go. They go clockwise. But yeah, I thought this would be very appropriate.
Yeah.
The reason why forecasting the track is so difficult is because that high is not circular, and it doesn't always sit and move in a nice way. It has squiggles and wiggles, and you just don't know what clock face you're looking at, really. So that's what makes it tricky, is that it's always an evolving atmosphere. And here's a couple of examples, actually. So I do my own forecast for when I do my blog. And so I look at the pressure fields. And this is Tropical Storm Faye that visited Florida in 2008. And in fact, it was August 19th, 2008. And here's Faye, the low. And this, here is Florida. I don't know if you can see that very clearly, but there's Florida.
I think that you can see the green and red.
You can? Oh, okay.
They see it better. We can't really see it so well
good.
from here.
And then here is the high. So you see it's not smooth or round at all. So this was August 19th. And this is...
So on this one then, because the high is way over here, the low has to stay, it's forced to be here.
It's basically following this around. So what Tropical Storm Faye did was she did a tourist tour of Florida. She visited the Keys, and then she went over and hung out at the Kennedy Space Center for a while. And in the meantime, the high had developed, so then she was zoomed over towards, if I recall correctly, Tallahassee. So she did this zigzag across Florida.
So the high came even further over to Florida.
Yeah, yeah. So as she moved around, she was still trying to go in that direction. But
and where did she end up? Just going?
I think she went in, and she just, I think.
Went up there?
Yeah, I think she just dissipated somewhere inland. So that was August 19th. So this is Gustav. This is August 26th of the same year. So this is like just a week and a half later. And look how different the high is now. It's very different. So Gustav
and this
actually...
is still the Bermuda-Azores high.
Yeah, yeah. And so Gustav actually tracked into the Yucatan area, if I remember correctly. Didn't come up to Florida at all.
So in a way, the high protected us.
Yeah.
Yep. Okay.
Yes?
So this is a map then of other things that affect us, the different currents. So the Yucatan current, then the loop current, the Straits of Florida, the Florida current, and then it goes up to the Gulf Stream, and the loop eddies that come off of the loop current.
Right.
So we know from the oil spill about the eddies and the loop current. And so what exactly role does the loop current have in tropical storms and hurricanes?
So what I was talking about was tracks. And the loop current influences the intensity. It's a different thing entirely. The loop current, in fact, this entire current system is, compared to the water around it, it has a lot of warm water, very deep warm water. And so as a storm passes over and churns up the water underneath, it's churning up warm water instead of cold water.
When it goes over these
When
currents.
it goes over these, yes. So a storm that's, for example, approaching here, like Hurricane Andrew did, this is an area to watch out for because, again, it's crossing deep warm water. And so it will intensify. And so Hurricane Wilma that came across in 2005, Rita came this way, Katrina came up. They all crossed the loop current and they all intensified.
And how about this loop eddy? Is that really hot?
Yeah, that's a break. It's essentially a break off of the loop current.
And why does the loop current change shape and form?
I don't know. That is a really interesting question. And, you know, it's one of those things that really requires more research because it's this massive thing in the Gulf of Mexico that we don't have an understanding of to the extent that we need to be able to predict it. And Bob can correct me if I'm wrong on this. But we do. I mean, we need to be able to figure out why it's doing that and where it's going to be a month from now and all of that kind of
Well,
stuff.
that's, to me, very exciting that there's this thing called the loop current, which we've all become familiar with because we all are obsessed with tropical storms, at least I am. And here's something that a scientist, a really brilliant scientist, will be willing to say, you know, I don't know. And that is a mark of an educated person, that they're willing to say, I don't know, but we need to do research on that. And, you know, they're going to get lots of millions of dollars, and this is an important feature of our system. And we know that it was, people looked at the loop current and the loop eddies during the oil spill, that, you know, people looked at that. So, so exciting.
Yeah.
It's exciting for us to know that new research is,
Right, right.
Okay.
Okay, so here's an example. This was Katrina. Who can forget Katrina, 2005. And the color, this is the track she took. And the color code is the intensity of the storm. She was a tropical depression, tropical storm, a category 1 as she crossed southern Florida. Cat 2, Cat 3, Cat 4, Cat 5 here, and then back down. And I think she made landfall barely as a Cat 3. But so this was the track. And this map shows the sea surface temperature. And when you listen to hurricane forecasting, it's always, you know, sea surface temperature. And that is very important. It has to be a certain temperature. But what you see is when she intensified, she was actually going over warmer water at the surface, at least. But over here, we have an indication of the loop current. And the reason it's red is because I said it was a lot of warm water. Warm water expands. So this map is actually a topography. It's like these are the hills. The red parts are higher, but in the water. And the blue parts are lower because it's colder water, relatively speaking. And so what you notice is she actually intensified as she got over the loop current, and she continued to intensify and continued to intensify, and then started to de-intensify as she got away from there. So what happens underneath the surface is really important.
So what we've learned so far then is that where the position of the high pressure really matters, what the temperature of the water is, the sea surface, but also
What's
the deep
underneath.
water
Yeah.
really matters. Because we saw that in Debbie, that there was a lot of cold water underneath and it kept churning it up
Yeah.
and affected.
Yeah. Well, I mean, on the West Florida shelf, we have a very broad, shallow shelf. So there's no room for that much warm water.
Mm-hmm. Mm-hmm. So if we know that warm water intensifies storms, why isn't there a way to affect that? Like make the water cooler? Like I used to have always a theory that we would put lots of ice cubes in the water.
Yes, there's about, I don't know, 10, 12 suggestions
Right.
of how to get rid of hurricanes, from nuclear explosions to ice cubes.
Right. So why is that unrealistic?
So the problem is, I think, normally you look at it on a map, on a satellite picture, and it's this thing, little thing. In reality, they are massive. Some of these storms are huge. So some of the suggestions made, for example, nuclear explosions, not a good idea. There was an idea of putting black soot in a storm.
Soot?
Yes,
S-O-O-T?
yes, to absorb some of the heat. I mean, these are just ideas that are thrown out there, and it's great. People are creative.
Sure.
But but the physics doesn't allow for it. In some cases, the physics just doesn't allow for it. In other cases, you would need so much of whatever substance they are proposing that it's just not a feasible thing to do.
Correct. I mean, I really explored through lots of drawings this whole idea of ice cubes and did this extensive drawings. And I realized through that, I mean, one of the problems was, well, how are you going to produce these ice cubes, right? What sort of heat was going to come off of the, so you'd have to use solar to produce the ice cube. You know, so you're really affecting the environment. And then what about the ecology?
That's
There's
the other
all
piece.
sorts of ramifications when you follow through a lot of ideas.
Right, and the other thing about hurricanes and tropical storms is they're part of nature. And they're a way to transfer heat from the equatorial and tropical regions really quickly and effectively to higher latitudes. So if you mess with hurricanes, you're messing with the entire system, the entire planetary system. And also, I mean, so you can put stuff in the water, but then what is it going to do to the ecology?
Exactly.
Yeah.
Yeah. It's a good thought experiment to think about. Well, you then
After a
end up
few.
thinking about all of these
After a few.
connections. Okay, so, beautiful.
Yes.
Scary, but beautiful.
Yeah, so this is 2004, and this shows Hurricane Ivan, what became Hurricane Jean before she became Hurricane Jean, and Hurricane Carl. And actually what's interesting in this year, there's one that's missing, Gustav, G, whatever the G storm was, George, I think, no. Anyway, there was a G storm, but the 2004, that was the one of 2 times that we've had 4 storms simultaneously in the Atlantic Basin. So this is just 3 of the 4. It's the G storm, whatever that was.
But this picture is so wonderful because they always talk about waves. And this really shows their waves. And I mean, you can imagine being in the ocean and diving under them, you know, these giant waves. And it's such an
don't recommend that.
astonishing photograph.
Yes, this is one of my favorites.
Yes, it's on your blog.
This is my blog. Yes. Yeah, I grabbed this in 2004 from NOAA, from the GOES satellite, because it is just a stunning image.
And frightening.
Yeah, yeah. Ivan went up to the Panhandle area and broke a bridge on the I-10 or something.
Yes.
And Jean, we know, came into Florida.
Oh, here it is.
Oh, there we go. That's Jean. Yep, that's where I was.
They're beautiful, though.
They are.
I mean, it's
They
really
really are.
stunning. Okay, so
Haha. So, this is some of Bob Weisberg's work, him and one of his research associates, so I can't take credit for this, but I'll talk about it. This shows the storm surge if Hurricane Ivan had come into Indian Rocks Beach.
right. So it's just a model.
It is a model.
Yeah.
And it's using
Not what
the
really
winds.
happened.
No, it's not what really happened, but it's using the winds just to show what would have happened in terms of storm surge in the Tampa Bay area. And so what you have is the water level. It's in meters. You multiply the number by 3 approximately to get it into feet. And you've got, this is prior to, I think this is the storm here. So this is a few hours before. So this is maybe at landfall. Is that right, Bob? Yeah, at landfall. And so you see that the water levels, this is Fort DeSoto, just to give you some orientation, the St. Pete beaches. And the elevation, the yellow is 3, I can't see from here.
3. So it'd be 9 feet.
There's 4.
Yeah.
So, yeah, somewhere around 9 to 12 feet, 9 feet or so, right? So that's the yellow. And you can just see how different our coastline looks. This is, the second one is the bridges. Here are the bridges. So this side is Pinellas. There's Hillsborough. The bridges have gone, so there's no
way out.
What you don't see here, though, is that, because you always assume we're in Pinellas, we can just drive north, but there's actually a dip. And so the northern escape route also gets cut off. And so Pinellas becomes a series of islands, basically, at least for a few hours until, or maybe a day until the surge, until the water starts to
And that is
get
one
out, but
good
it could
thing
be
about
longer.
Pinellas, though, that the water would go back.
Yes, we're not like New Orleans. We're not below sea level for the most part. And then this is Tampa, the old Tampa port area. So,
Okay.
is there? I don't. Bob, do you want to add anything to that?
So those elevations are relative to land. And so the entire portion of northeast St. Petersburg would be in a lot of trouble.
Yeah.
If we had a direct hit at Indian Rocks Beach.
And Apollo Beach, Apollo Beach is probably the worst place, and that's the area under the most development right now. Or at least it was before real estate market crashed.
Yep. Yeah, we're looking at 15 feet of water at least
Wow.
above land. So.
Okay, let's pretend that that's not happening.
Okay.
It's gone.
She's so optimistic. No, I'm kidding. Okay. So if you ever want to look at this, where the water is if a storm is approaching, there is this website. It's a NOAA website. It's called Tides Online. And you can go and you can click on...
tidesonline.nos.noaa.gov.
Right. And you can click here. It says state maps. And so I did, and this is Florida. And it shows a number of water level gauges around Florida. And so
You just click on
you
that.
can click on St. Pete, and it will show you what the tide, the predicted tide is according to the lunar cycle, what the water level gauge is actually showing you, so whether it's above or not, and then the difference. And so you can see anywhere around the coast what's going on.
Oh, wait.
Yes, so Molly sent me these during a tropical...
Who's Molly? Yes.
This is her car. This is in Shore Acres.
Yeah.
Tropical Storm Debbie, just a few weeks ago. So this is normal traffic
Storm
during
surge
a storm.
and rain.
Yeah, the combination. So there's your normal mode of transport. And there's the new and improved mode of transport. Oh, yeah.
Okay, so now we're going to look briefly at ways of finding information about hurricanes. So this is you in the cockpit of a hurricane hunter.
Yeah. Yeah, I got to go on a field trip.
Yeah, I'd love to go up on one of those.
I didn't actually go up.
Yeah.
I just
Wow.
went to visit.
That'd be so
I'm
cool.
still working on the going up part.
And what does the hurricane hunter do?
So there's two entities that fly hurricane hunter planes. One is the Air Force and the other is NOAA. And NOAA predominantly focuses on research. And so it's the Air Force that normally provides us with the day-to-day information on a storm. But NOAA does fly
And
through
does it
if
fly out of
needed.
MacDill?
Yes. No. Yes. Yes, they do. They fly out of MacDill. And they just go through and they drop, as they crisscross through the storm at different heights, and they drop instruments through the storm. And so you get a vertical sounding profile of winds, temperature.
Now, wait a second. When you say they drop instruments, they're like tethered to the plane?
No, because that would be
They let them go and
Yeah.
they can communicate with them
Yeah.
through satellite
to
or
a certain point,
radio?
Yeah,
Or?
satellite,
Hmm.
So,
Okay,
yeah,
then
that was
another-
just me. The interesting thing I learned was that the NOAA planes are named after the Muppets.
Oh, really?
So that's Miss Piggy. I'm sitting. there's a froggy and yeah, the Gizmo I think was the third one.
So another way of collecting information are from these buoys.
Yeah,
And this actually is in the Pacific.
this is actually.
And this is
Yeah.
you.
Yes, that's me, and I think that's me too. And there, I think I might be hidden back there. And actually, this is Rick Cole, who's also in the audience. This was part of my PhD when I was working with Bob. So that's why we're in the Pacific. And it's interesting, actually, because when you sail out, there are sharks everywhere. Can I just tell you?
Yeah.
Everywhere. And so if you stop and you're stationary for a while, which you are when you're doing operations at sea, after about an hour or two, the sharks start to come circling around the vessel. If you throw, your kitchen garbage over, there they are. So I like to say that this was me and Rick in shark-infested waters with no tether. Bob's just lucky I didn't fall off.
So this shows how the buoy is set up. Can you explain that,
Yeah.
please?
So this is actually one that's on the West Florida shelf. This is one that I got most of my data from. And it has, above the water, it's got meteorological sensors. So it's got wind, it's got air temperature, pressure, the solar radiation. So it has a bunch of stuff up here. And then under the water, what you don't see are a string of sensors. So this is called an acoustic Doppler current profiler. It measures currents. And then there's temperature and salinity meters throughout the water column.
And then it's tethered to the bottom of the...
Yes, by railroad wheels.
Oh.
Pretty heavy railroad wheels.
And this shows how we can get this information.
Right. So this is a schematic. So because of funding issues, not so many are now out there. But this is what an ocean observing array would potentially look like. And you can put anything on here. You can put chemical sensors and biological sensors hanging off these platforms. And so the idea is that's where we are, just so you know.
Is that your satellite over there that collects the...
This one?
No, this.
That's
Is
a
that your
satellite
dish?
dish. Yes,
Yeah.
so anyone who's been to the College of Marine Science, you'll see a satellite dish. That's that satellite dish. So the data is transmitted via satellite back to the lab, and it's processed there. And you've got a whole array of stuff. You've got some that just sit under the water, and you can pull them up later, and they've got a long data set that they've accumulated.
And then this is the web page you can go to
Right.
get this information.
Right. So this is the comps marine.usf.edu, and this is all out of Bob's lab.
And all of this comes right here, from here.
It comes right from
Yeah,
St. Pete.
It's amazing.
Yeah, it's all done from here.
Mm-hmm.
And so you can click on these, and so this is C12, which I think is this one. And so what you do is when you go to this site, you can see what the wind is out there at this moment, more or less, in time, or the temperature. And so when there's a storm coming, I go to these and have a look, because you want to know what's going on out there.
Right, exactly. Okay, so now we're back at the block. So one of the questions is, you know, the Indians loved St. Pete because they thought it was a safe place to be. And we've had this discussion. So you explained to me in scientific terms why the Indians might believe that. So why, for example, a Category 4 or 5 hurricane, it'd be very difficult statistically for it to hit directly at St. Pete. So could you explain that?
Sure. So if you remember back to the image I had with all the January, all the months, and how I said, it's way back.
Yeah, I get it.
That one. No.
This one?
No, one forward, this one.
Okay.
So we sit here, okay? And a lot of the Cat 4, 5 big storms generally come across the Atlantic, and then they come up either through the Caribbean and they cross the Loop Current, etc. But a lot of them do actually hit on the East Coast first. And
East Coast of Florida.
East Coast of Florida, because that's the way they generally track. If they come up through here, they tend to actually head towards the northern Gulf Coast.
And why do they do that?
Well, usually we are protected by that high pressure system. If they do come across to us, they do de-intensify. I mean, we've got that huge West Florida shelf that they have to cross. So that's the big storms. The storms we really need to watch out for are the early and then the late season
Now,
storms.
why aren't there any early Category 4 or 5 hurricanes?
Because things are still warming up.
So the water's too
still
cool.
Yeah. You're
And is
coming
there
out of
high
winter.
wind shear then? Higher wind shear?
Sometimes, not always, that I've seen anyway. And that's why we get some at least. But we are coming out of winter and into summer.
So I know that, you know, ships come here often in the summer to protect themselves. So is that really, so you think statistically, I don't want to make anybody optimistic, but do you think that it's statistically low that we would have a direct hit here of a 4 or 5?
I would say statistically, yes. I wouldn't say it's impossible.
Right. But how about a 1 or a 2 or a 3?
Yeah, we can. Yeah, that's a definite possibility. I was going to say the early season and the late season storms when they develop in the Gulf or in the Caribbean. Those are the ones we have to. I mean, we have to watch all of them. There's no doubt about that. But statistically, then, we do actually get hit or we get grazed every 2 to 3 years. And when I mean grazed, it's within 60 miles of Tampa Bay. So every 2 to 3 years, we do get something, and that's statistically.
Well, that's all we can hope is to
but
get
if it
some
comes
statistical
right, but if it comes
explanation.
across from the East Coast, then it's usually downgraded a category or 2 by the time it reaches us.
Because of the crossing of the land.
Yeah. Again, it depends how fast it's moving too. If it's a fast-moving storm, then it doesn't have as much time over land.
So what's been the biggest storm that's hit Florida?
The most intense, I think, we made 1928, the Great Miami Hurricane. I think that had winds of about 185 miles per hour. So a very strong Cat 5. And
did it impact St. Pete?
I don't. Well, I think I don't know. It probably did, actually, because I think it tracked up to the Alabama. So there must have been some impact as it crossed from Miami. And there have been studies that have been done that if you took that storm and you had it go take that path now, the damage would be, say if you took it in, when Hurricane Andrew went through, that was 20 years ago, similar kind of track. The damage would be something like $70 billion in South Florida, with another $10 billion or so in the Alabama region. So Hurricane Andrew was a $25 billion or so damage in 1992. If you took the Great Miami Hurricane, it would have been substantially more. So that would have potentially been, so that I think would be the biggest from that perspective. And I think if you took it and you did the track in 2005 and compared the damage to Katrina, Katrina actually comes in third as far as normalizing the economic damage. Yeah. So that would be the largest.
Okay, so this is you as a storm. And now we have another aspect of you.
Oh.
So Jyotika has recently been married, and her husband is here, Ben, and he flew in from LA last week, so he could be here. And before I even knew Jyotika, we were at Jan's place in the Cloisters, sitting on their balcony, and we looked out at the MFA, and we're like, wow, look at all, this is a wedding from India. And it was Jyotika. Wow, look how beautiful. So,
I know, what are the odds?
Yeah, right, exactly.
Are you stalking me?
Yeah. Right. So one of the things Ben does, the reason he's in LA, is he makes films. And so this is a film that is going to premiere in California in September. And there are people in this room who are involved in the film. And could all of you raise your hands or stand up? Anyone connected with this film?
Well, there's two at least.
Yay.
Three.
Oh,
me.
All right. And you're the,
yeah.
What are you in this? You're in the credits.
Yeah, I am.
What are you, the producer, the associate executive?
Yeah, I'm credited as executive producer. And we've gone back and forth over this. But so this film is a short. It's a Western, obviously. And it was written here. Ben he wrote this in St. Pete a couple of years ago. And so I've been involved, like I think I've read every version of the script, of which there have been many. And then I helped with setting up some of the behind-the-stage stuff. And I went out for the filming, and my fantastic job as executive producer was to make cups of tea and to drive the actors up and down the mountain where the film location was, which was great. So that was my job.
Yes.
Go and get the
Very
lunch.
important.
Go and get the lunch.
Yeah.
So, but yeah, so I did a bunch of stuff. So,
so we're looking forward to a St. Pete premiere, and we're going to try to find a place to have it, and maybe it'll be in October or November, and
yeah,
be great.
Yeah.
So there she is. This is how one ought to remember.
And they will.
So we have a few minutes, and who has a question? Yes, could you stand up and say who you are? And
yes, my name is George Saltzman. I just wondered what the FIO had to do with the R111 modeling that affects how the insurance industry charges for property insurance.
whoa. So I'm just going to say this for the people next door so they can hear the question. So the question is, what does the Florida Institute of Oceanography and what they do have to do with the property insurance that we pay and influence? The modeling.
She knows what
Okay.
I do. We actually have nothing to do with it. Because, I'll tell you why.
Yes, that's what
Yeah,
they
I'll tell you
all
why.
say, right?
I'll tell you why. Because the models that are developed that determine your property insurance for storms, etc., are done privately. So it's the insurance companies that have those resources. There are large, and those are essentially behind closed doors to those of us in the academic and other arenas. So really, we have nothing to do with it. I mean, there'll be people who have obviously trained in universities who go and get jobs with insurance companies and who will work on those models. But as far as I know, they get paid a lot.
What you're
like me.
what you're suggesting is maybe something like the Florida Institute of Oceanography, being an objective institution, could be making these models instead of a group of people that may be self-interested. Well, that's a very interesting question, and maybe new research.
Do you have anything to add to that, Bob, or is that?
No, actually, I will add something. So,
Here.
Aha.
Here's a microphone so they can hear next door.
Okay. I've worked with Bob so long I can read his face now.
So,
It's
can
true.
you say your name again, because
Bob
I don't think
Weisberg.
people can see you.
Oh, Bob Weisberg. Well, there's two different types of insurance. There's the flood insurance and the rest of it, the wind and liability. The flood insurance is underwritten by FEMA, and it's just sold by the insurance companies. And so there are large engineering firms that get these zillion-dollar contracts to do flood insurance rate maps, and that is fairly objectively done. But then when the flood insurance rate map gets promulgated, it goes through a political process because nobody wants to pay for flood insurance. And so there's a lot of sausage making going into ultimately what your flood insurance costs, and but it's probably the best thing you can ever possibly do, as people in coastal Mississippi found out when they didn't have it. But then there's the rest of the insurance, the wind insurance. And unfortunately, because of all the losses in Mississippi with Katrina and all the lawsuits that followed that, private insurance companies don't want to underwrite wind policies anymore, anywhere around the Gulf of Mexico. So I don't know how they determine rates anymore, and I don't know if Florida Institute of Oceanography or any objective group can do anything about that. That's become a purely political process because the private concerns have upped and left.
And the reason I asked Bob is because after Katrina, he served on a national external panel of some description to do something.
exercise.
Yeah, right.
Yeah, no, the National Academy put together
A panel, and so I was asked to serve on that. And that had really to do with determining what went wrong with the levees in New Orleans, and that's another interesting topic. But I got to learn a lot more about flood insurance and wind insurance than I ever thought I would. It's a difficult problem, as you might expect, once it becomes political.
Thanks, Bob.
Okay, thank you. Who else has a question? Yes, could you stand up and
Winnie Wilson from
there? Use the mic, okay?
I'm Winnie Wilson, and I actually got my master's through USF in marine science. But my question is, have you ever been in a storm, in a situation where you were trapped when a storm was occurring?
No, I haven't actually.
Oh my! No, I just have.
Well,
go ahead.
I mean, yeah, I was here for 04 and 05 with everybody else. I was fortunate. I think my power went out for about 10 hours. One of my other neighbors, Joel, came over and we had ice cream and,
Before
and
it
wine.
melted?
Before it melted. I mean, it's very important, right?
Right. Don't want your ice cream
And there's
to
no
melt.
air conditioning, so it keeps you cool. It's great. You know, but I was only out for 10 hours. I know colleagues of mine were out for a week.
Well, it is a very frightening situation. I happen to be a Navy daughter, and I was in Newport, Rhode Island for that severe storm that hit back in the it was in the 80s, I know. And we had to evacuate. We were living right on the coastline there in Norfolk. And we were fine, but it was scary.
Yeah.
And we had to walk up the hill.
Yeah, it is.
Because we couldn't get the car out of the driveway.
Yeah,
Yes.
I think
So it was
very
amazing.
scary.
it's very scary. If here, I would evacuate for a Cat 4 or 5. There's no question. No question. Get out. A Cat 3 is, you could withstand that, but you'd have to be very careful. Where I live now, I'd have to evacuate anyway. We saw, Tropical Storm Debbie.
Right.
It was a tropical storm. It wasn't even a hurricane. And that, they do spawn tornadoes. So they do cause a lot of damage, regardless. One thing that we do say is you run from the water. So if you're in a storm surge area, get out. And you can hide from the wind. So you can get under, inside. And
Right.
if you are stuck.
So who else has a question? Yes, could you stand up, please, and say your name?
Arthur Feingold, and you had a picture of my neighborhood. I don't want to highlight the name of it. But 3 weeks ago, like on, I guess, Sunday or Monday, was there a way for me to predict how much higher that water was going to rise? Was there any idea what would happen over the next 12 hours, so I would have known to get out the kayak or hide the car in high land, or just what to do at that point?
That's a good question.
Yeah. Yes, there are models out there that do predict the storm surge. Noah's model, which
That
is the
one?
one that we normally
The one we looked
No,
at?
that was
Oh.
Bob's. But Noah's model that's normally, that they normally tell you it's going to be this much storm surge, is not high enough resolution. So for all the islands and bays and stuff around here, it's just a very broad approximation. What you need is something like the model that Bob has, which does go down to, what's the smallest resolution? Do you remember?
That was about 100 meters.
Yeah. So something like that. But I mean, that's, it's an academic environment that works in. It's not a 24/7 operation, right? I mean, it could be, but.
Okay, one more question. Who has the final question? Noelle. Okay.
Oh.
Noelle Smith. Do you expect any changes to these models with global warming or global climate change in the future?
Do you mean to the models or the storms?
Well, yes, exactly.
The storms, right? The storms, yeah. It's interesting. There was a huge ruckus a few years ago because there were people after 2004 and 5 who came out and said, "This is it. This is the end. It's going to get worse and worse," and it didn't. And actually, that was when I was doing a postdoc, and I wrote a paper with Bob to show that 05 was not anomalous. It's happened in the past. 1933 had 21 named storms, but that was in 33 before aircraft. So those were only the storms we knew about. And there have been other times where there have been frequent storms. So there'll be some changes, but I don't think it's going to be as big as they have, those, as was indicated back then in 05 and 06.
Okay, well,
You love that picture.
I
don't
love
you?
this photograph. Thank you for coming tonight. The reason I love this photograph is because,
Do you want me to say where it was?
yeah, say where it is.
Okay. Okay, so she's alluded to this, so I might as well. So I am a big science fiction fan, and this was taken at a science fiction, fantasy, pop culture convention that I go to almost every year. This is where I met my husband. A number of my friends are in the audience who go there with me, and we have a great time.
And you dress up.
Once in a while I do dress up. And in fact, Tim is in the audience. He took this photo, and I remember...
And he photoshopped it a little.
But, actually, another friend of mine photoshopped it.
okay.
But I was standing on a staircase and just,
Yeah.
posing. And so that's why I dressed as Storm.
From the movie.
Yes. Yeah.
X-Men.
Yes.
So, okay, so the reason I like this photograph is because we think of people who do science as being, boring and cold. And I love science. I did a lot of mathematics. It's so elegant, it's so beautiful, and it's so exciting. And this to me is a scientist. It's somebody who's creative, who's being able to step outside the norm in order to see where things can go. It's about being creative. She's not a mad scientist. She's a brilliant scientist. And I want to just commend all of you in this room who are part of that community, and all of us who are connected with it through academia, through being artists, through being creative filmmakers, and so on, because it's this energy that is what's going to move us all forward. And I think this is the symbol of science to me, and what we should think of it as. So I invite you back next month, August. Now, in August, it's a week, so it's the third Thursday. It's not the fourth Thursday, because the last Thursday is the GOP. So we're not doing it then. We're the week before. So pay attention to that. And
Who is it?
it's a mystery.
Oh, okay.
So I invite you to come back, and I invite you all, along with me, to thank Jyotika Virmani.
Thank you. Thanks. Thank you all.